Hey guys, I'm gonna go over the FRQs for the upcoming Chapter 7 test, and maybe while I'm at it, I'll catch a couple of spelling errors, but we'll see. So for this first one right here, we have the depth of seawater at a location can be modeled by the function h that satisfies the differential equation. This just means that this is the derivative of h, where h of t is measured in feet and t is measured in hours after noon. So noon is being measured from time t equals 0. It is known that h of 0 is 4. So that's an initial condition. For one, a portion of the slope field for the differential equation is provided. Sketch a solution curve y equals h of t through the point 0, 4. So sketch a curve that's going to fit in the slope field, but also is going to pass through this point. So honestly, really not too difficult of a problem. Just try and follow the flow of the slope field. Something like this right here should be good. Try and follow the tangent lines as possible. And then as I go through these, I'm also going to go through the scoring guideline. So for A, what are you going to be graded on? So it's worth 1 point. The solution curve must pass through the point 0, 4, extend to at least 4.5, and have no obvious conflicts with the given slope lines. Only portions of the solution curve within the given slope field are considered. So I think mine's pretty good. I'd give myself a point if I do say so myself. Let's move on to 2. Now, question 2 is not really Chapter 7 related, but that's how it's going to go on the AP exam. You're going to have questions that are mixed with different concepts from other chapters. So it's actually really good that we kind of review some of these. But for 2, it says from 0 to 5, we're still talking about the information from up here. It can be shown that h of t is greater than 1. Now, on this question, we cannot refer to this graph for points. Okay, it's going to be very tempting to be like, yeah, look up here. But you can't do that. So h of t is greater than 1. You can kind of see that a lot of these functions. So here's 1. You can see that our given function right here is greater than 1. So find the value of t. So along here, find the value of t. Which h has a critical point. So remember that h has a critical point. That's when h prime, or I guess we should say dh dt, that's when dh dt will be equal to 0. So let's first find that. Well, I have dh dt given up here. So what you're going to want to do is take dh dt and set that equal to 0. So it's equal to 1 over 2 h minus 1 times by cosine of t divided by 2. Alright, we're going to set this equal to 0. And now you can't necessarily solve for t in this right here. You have to just use more reason and logic. It's not really mathematical. So we're trying to find a value of t that's going to make this 0. So what do I do with all of this right here? Well, this factor right here, so it doesn't matter what all of this is. 1/2 is not going to play a role in whether or not this equals 0. Also, h of t is greater than 1. So that means h is greater than 1. Well, if h is greater than 1, then this won't be 0. So if I have a product using the 0 product property, if I'm setting this equal to 0, either h has to be 1, because if h is 1, then this is 0, then the whole thing is 0. Or cosine of t over 2 has to be 0. And since h can't be equal to 1, we don't even need to consider that at all. We don't need to consider this being equal to 0. So the only possible way that our derivative, h, will have a critical point is when cosine of t over 2 equals 0. So when does cosine of t over 2 equal 0? And remember that t has to be a value between 0 and 5. Well, when does cosine equal 0? Cosine is equal to 0. If we think about a polar curve, cosine is equal to 0 at pi halves, and that's pretty much it. Obviously, we're going to have 3 pi halves and then 5 pi halves, but remember that that we have to be within this very small interval. So we know that cosine will be 0 whenever we have a 90-degree angle, or pi halves. So that's pretty easy. So I can say that cosine of pi halves is equal to 0, and pi is like 3.1 something and whatever 2. So look at this right here. If you compare these two right here, this would mean that t would have to be equal to pi. So there you go. So when t is equal to pi, that's when you're going to have a critical point. So there you go. And that matches with our curve up here. If you look around 3, which is 3 is around, pi is around 3, look at this right here. That's where h is going to have a critical point. Again, you can't refer to this graph right here and say, maybe around 3. You're not going to get a point. If you say, maybe around t equals 3, we're going to have a critical point, because that's where that's where it has a derivative of 0. T equals pi would be a good answer. So when t is equal to pi, our derivative will be 0. Okay, so far we're doing pretty good. Now it says determine whether that critical point corresponds to a relative minimum, relative maximum, or neither, and justify your answer. Now I know you can look at this graph right here and be like, obviously this is going to be a maximum. These slopes are positive, these slopes are negative, so it changes. But you cannot use this graph up here as justification, unfortunately. But you can use it as verification, because you now know, according to your graph up here, that it's going to have a maximum right there. Now, we can use 2 different tests to verify relative minimum or maximum. If you remember from chapter 5, we can use the first derivative test, which is what I'm going to opt out to use. So we're going to have 0 as our endpoint, 5 as our other endpoint. We know that pi is in between. I need to verify values in between here. I know that the values here are going to be positive. I know that the values here are going to be negative. So this is a good thing, because now you just have to make your math work like that, right? So we want to show here, we want to prove that h prime is positive. And here we want to prove, somewhere in this interval, we want to show that h prime is negative. So what's a value that we can plug in right here? So a value between 0 and pi that we can plug in for t to show that it's positive. Let's see. So let's think about this. If we say this is this right here, pi, so if that's pi, all right, what if we do pi halves? So pi halves is going to be a value in between here, directly right in the middle, actually, so right in between pi and 0. Let's say we do pi halves. Let's give it a shot. So if I plug in pi halves, keep in mind here, h prime is here. H minus 1 is always positive, because h on this interval right here is always going to be greater than 1, so that means this is always positive. So, and then we know that 1/2 is always positive, so we just have to prove that cosine of t over 2 is positive. So cosine of pi over 2 divided by 2 would be cosine of pi fourths. And cosine of pi fourths, so let's think about cosine of pi fourths. What is cosine of pi fourths? Cosine of pi fourths, well, that makes a right triangle. You don't actually have to do this part. I'm just trying to find the value. So cosine This is 1, 1, and root 2. Cosine is equal to 1 over, cosine of pi fourth is equal to 1 over root 2, which is positive. So therefore, we're positive here. Okay? And then, well, let's say we do, what's a value between, so this is pi fourth. What if we do 3, is 3 pi halves okay? Is 3 pi halves, I don't know if that's actually between, let's see, 3 times by pi. I'm going to cheat. No, I'm not. I'm better than that. I'm not going to cheat. So 3 pi, which would be somewhere close to 9, a little bit more than 9. And then if you divide that by 2, that should be less than 5, right? Trying to see if there's any reason as to why that wouldn't be less than that. Or is there something better that I can plug in? So I got pi. What if I just, so this is pi halves, pi. Yeah, what if I just do 3 pi over 2, right? I don't know if that's going to be very nice to, oh wait, that's what I said before, right? So 3 pi over 2? Yeah, let's just do 3 pi over 2. That should be fine. So, I mean, we could plug in like a whole number 4. But if you plug in 4, then you get cosine of 2. And that's harder for me to decide if cosine of 2 is positive, especially if you don't have a calculator, which this is non-calculator. So I'm going to stick with 3 pi over 2. Because I'm pretty sure that's going to be less than 5. Because 3 pi, that's going to be 9. That's going to be less than 5. Okay. So if I plug in 3 pi over 2 in here, remembering that this is always going to be positive, so then I'm going to have cosine. So if I plug in 3 pi over 2, that's going to become 3 pi over 4. 3 pi over 4. Now 3 pi over 4 would be, that's 1 pi over 4, 2 pi over 4, 3 pi over 4. So 3 pi over 4 would be over here. Thus, that means this would be negative 1 square root of 2, and cosine of that would be negative 1 square root of 2. So it's equal to negative 1 over root 2, making it less than 0. So therefore, it's less than 0. That's greater than 0. So because dh dt changes from positive, I should spell it out, to negative. I could probably even just say changes signs at t equals pi. It is a relative maximum. There you go. So there's our justification. Let's go ahead and read what we have for our point. So this is a 3-point question. So the first point, consider sine of dh dt. So the first point is earned by considering dh dt equals 0, dh dt greater than 0, dh dt less than 0, cosine of t over 2 is equal to 0, cosine of t over 2 is greater than 0, or cosine of t over 2 is less than 0. Lots of options. I did pretty much this right here and that right there. That both of these would have covered that right there. So dh dt is equal to 0, or that right there, cosine of t over 2 is equal to 0. So there you go. That's how you would get that 1 point right there. And then the second point comes when you identify t equals pi, which, there you go, t equals pi right there. So the second point is earned by identifying t equals pi, with or without supporting work. So that's a plus. A response may consider that h is equal to 1 or t equals 1 as potential critical points without penalty. All right, I don't care too much about that, but all right, the third point cannot be earned without the first point. So if you don't earn the first point, you're not going to earn the third point. Okay, so keep that in mind. The third point is earned only for a correct justification or a correct answer of relative maximum. Justification can be shown by determining the sign of dH dt at a single value in 0 to pi and at a single value from pi to 5. So which is what I did. I determined a value between those right there. It is not necessary to state that dH/dt does not change sign on these intervals. So I don't have to prove that in between here that it changes signs. So I don't have to prove that it changes from positive to negative in between here or in between here. Don't have to show that. The third point can also be earned by using the second derivative test. I think the second derivative test would be a little bit more difficult because you'd have to take the second derivative of this right here, which if you do that, you'll have to use the product rule and implicit differentiation. And not only that, but after you use implicit differentiation, let me give you guys an example of what that would look like. So using the product rule, you'd have to do the first, so this is the h double prime, the first, which is going to be, no, yeah, is there an easier way? No, I don't think so. So the first, which is 1/2 h minus 1 times the derivative of the second, and the derivative of cosine would be negative sine of t over 2. I think I would have to multiply, I'm going to have to multiply by 1/2. So negative 1/2 sine of t over 2. So that was the first times the derivative of the second plus the derivative of the first. Now, if you were to distribute this would become a constant, so I'm not going to worry about that. But if I distribute the 1/2, then this is 1/2 h. So the derivative of that would be 1/2 of h prime, using implicit differentiation. So the derivative of the first times by the second. So cosine of t over 2. Let's see if that's what they got. Yep. That is. And then you have to prove that this is less than 0. So you have to prove that this would be less than 0, meaning that the shape is concave down, making this a maximum. This actually isn't too bad, as I thought it would, honestly. So you just have to prove that this is negative. So let's clean this up a little bit. So we have negative 1/2 and 1/2. That would be negative 1/4. You have h minus 1. And then you have sine of t over 2. Plus, then you'd have, is that what the same thing they have? 1/2 times by h prime, yeah, that's the same thing. So 1/2 times by h prime times cosine of t over 2. So the thing is, this is going to be, we're plugging in for the h double prime, we're plugging in, I don't think we have to plug in necessarily anything for h, but we're plugging in pi right here. So we're plugging in pi for t, and h minus 1 is going to be positive. So we're going to have negative 1/4 times by a positive number, sine, so if I plug in pi, we get pi halves. Sine of pi halves is positive 1. So times by 1. Plus 1/2. H prime at pi is 0. Yeah. H prime is going to be 0 pi. So that just goes away. Ah, nice. So if that goes away, we get a negative 1/4 times by a positive number. That's going to be less than 0. Yes. Okay, I'll be honest. I actually like this way a lot better. I thought it was going to be more difficult, but I think that required less work than this right here. I'll let you guys decide, but I think that this is actually quicker. So if you guys can understand that, maybe use this on the test if this is the one that you're going to use on the test. But yeah, so the idea is that this is your justification. So because h double prime is less than 0 at t equals pi, that means that it's a maximum. Because if h double prime is negative, it's concave down, and there's a critical point here, which makes it a maximum. So this would be the work that you would need right there, but cool. All right, yeah, let's go to 3. So for 3, use separation of variables to find y equals h of t, the particular solution to the differential equation given here. So now we're actually finding h of t at 0, 4. So we're going to have to use separation of variables. So what am I going to separate here? I'm going to separate this part. I'm going to divide out h minus 1. I'm dividing that out. So then I would have 1 over h minus 1 dh, and at the same time I'm going to multiply by dt, so that's over here. Keep in mind that I still have this 1/2 cosine of t over 2 dt. Alright, now that I have the separated right here, let's go ahead and take the antiderivative. Maybe I'll keep that on this side right here. So the antiderivative here is going to be, look, I have a linear factor, h minus 1. So this is going to be the natural log of h minus 1 equal to the derivative, the antiderivative of cosine is going to be sine. So we're going to have sine of t over 2. Now, we also have to divide by 1/2. So I have 1/2 here. That's for the constant, but I'm going to have to divide by 1/2 for the derivative of the inside, for the chain rule. So that's actually going to cancel. So I'm going to have the natural log of h minus 1 equal to sine of t over 2, and don't forget that plus c. Also, don't forget that you can always take the derivative in order to get back what you have up here. And then you can take the derivative here. So this derivative of sine is cosine times by 1/2, which is that right there. So I think this is good right here. Now I need to solve for c. And when it comes to separation of variables, I like to solve for c here. So I like to so I'm going to plug in 0 for t. I'm going to plug in 4 for h. So I'm going to get the natural log of 3. Natural log of 3 equal to sine of 0 plus c. So that means c will be equal to the natural log of 3. And I'm going to go ahead and plug that back in here. So the natural log of h minus 1 equal to sine of t over 2 plus the natural log of 3. And now let's go ahead and solve this for h. So we'll exponentiate both sides. So we'll get h minus 1 equal to e to the sine of t over 2 plus the natural log of 3. You can add 1 over here. So you can get h is equal to e sine of t over 2 plus the natural log of 3 plus 1. Okay. There is one thing you can do. You do not have to do this. Remember, you don't have to simplify. If you do simplify and get it wrong, it will be marked wrong. But I'm going to simplify because I'm going to get it right. So, because they do this all the time. Right there. I can write this instead as h is equal to e to the sine of t over 2 times by e to the natural log of 3 plus 1. So because this is addition and an exponential, I can split that up as a product, and then that means those could cancel, making this 3, which I'm going to put in front of here. So h is going to be equal to 3 sine e to the sine of t over 2 plus 1. And I really hope I didn't mess that up, because then I'm going to look really funny. So let's go ahead and check here. 1 plus 3e to the sine of t over 2. That's exactly what they have. But let me explain the grading here. So a response with no separation of variables earns 0 out of the 5 points. Not even doing this first part right here, no matter what you do, 0 points out of the 5. A response, so that's going to be, yep, separation of variables. So the second one comes from one antiderivative, and the third point comes from the second antiderivative. You can kind of see that on the left side here. And so let's see what they say. A response that presents dh, the antiderivative, as the natural log of h minus 1 without absolute value symbols earns that antiderivative point. So what they're saying there is that instead, you don't have to use absolute value signs. If you use the parentheses, or if you don't use those absolute value signs, then that's okay. They're not going to take away a point if you don't do that. A response with no constant of integration can earn at most the first 3 points. So if you don't do anything with this constant of integration right here, then you can get 3 out of the 5 points. If that makes sense. So if you get it up to here, you can have 3 of the 5 points, 1 for the separation, 1 for each antiderivative, okay? But then if you don't do anything for C, then you can't earn the last 2 points. And the fourth point, let's see. An eligible response earns the fourth point by correctly including the constant of integration in an equation and substituting 0 for t and 4 for h. So plugging in these values right here. Now, the constant of integration honestly might be different if you choose to solve for h here and then solve for c. So if you choose to solve for h first, then solve for c by plugging the point, your constant of integration might look different than this right here, but that's okay. Remember that once you get to the end, the formula should match in some way. There's just some algebraic manipulation that you need to do, but in any case, yeah, so but solving for the constant of integration earns the fourth point. A response is eligible for the fifth point only if it has earned the first 4 points. A response earns the fifth point only for an answer of h of t is equal to 1 plus 3e to the sine of t halves, or a mathematically equivalent expression, such as the one that I wrote before. So right now I have both. So you can leave it here, or you can simplify it here. Okay, like I said, you don't have to simplify your answers, but it does need to be solved for h. A response does not need to argue that the absolute value of h minus 1 is equal to h minus 1 in order to earn the fifth point. Okay, cool, whatever. I'm not really sure what the special case is, and I don't really want to read it because I've been talking about this problem for too long. Alright, I'm going to make another video for the next free response, but hopefully you guys found this one helpful, and yeah.